All right, this video is about chapter 4.1, congruent figures. So when figures are congruent, they have the same size and shape. When two figures are congruent, you could slide, flip, or turn one so that it fits exactly on the other one. So it doesn't matter if they are facing in a different direction, like for example in this picture down here, they might need to flip on top of each other. They can still be congruent as long as their shape and size is the same. And so when you have congruent polygons, they have to have congruent corresponding parts. So corresponding means matching in the same location. So their matching sides and angles have to be congruent to each other. And when you name congruent polygons, you're going to name them in a particular order. So for example, I can see in this picture that this sort of diagonal side is from A to B, and A is on the short side this way, and B is on the tall side. So A must be related to E, and B must be related to F, and so on. And you can sort of fill those in as you go. So if these two polygons are congruent to each other, then I'm going to write what is called a congruence statement. And this is the congruence statement, which states that these two polygons are congruent to each other. That's a congruent symbol in the middle. And the key is that these letters have to be in the correct order. They have to be with the corresponding part. So A corresponds to spot E, B corresponds to spot F, and so on. And then once you know that those polygons are congruent, then all of their corresponding parts must also be congruent. So these are their sides, or the segments that are in the polygon that are congruent to each other, and these are the angles, right? So I can see that segment AB must correspond with segment EF, so they are congruent to each other, and so on. Angle A is this angle here. That has to correspond with angle E, so angle A and angle E are congruent to each other. So this is called a congruence statement over here on the left, and then these are the congruent corresponding parts that would go with it. So here they're giving us a congruent statement. So they're kind of telling us which letters match up with which. Well, if this is saying that H matches with L and I matches with M, for example, then I know that segment HI must be congruent to segment LM. And so even though these are kind of twisted and turned, I'm using the congruence statement to help me match those up. Well, there are four sides of these polygons, so there should be four sides that correspond and that I can say are congruent. So I'm going to just go through the congruent statement and find their corresponding parts. So segment IJ, the middle two letters, have to match the middle two letters on the other one. Segment JK, which is the last two letters, has to match the last two letters of the other. And again, I'm doing it in a very just sort of organized way. And finally, you have to realize that H and K also create a side. So first and last, L and O must as well. So HK is congruent to LO. Finally, those are the sides. The angles have to also be congruent to each other. These are easier because angles only need one letter in this picture. So angle H is congruent to angle L. They're in the same location in the congruence statement. Angle I is congruent to angle M. Angle J is congruent to angle N. And angle K is congruent to angle O. Again, they are in the same location in their corresponding polygons. Okay, I'm going to let you do number 2. It's the same idea. We're going to have 3 pairs of sides and 3 angles. All right, so this is telling us that triangle WYS is congruent to triangle MKV. So I'm going to write the letters in the same order, WYS and then MKV, so that we can see that visually they will match up with the corresponding sides. We're being told that angle W is 62 degrees and angle Y is 35 degrees. We're asked to find the measure of angle V. Well, interesting, because V is not in the same triangle, but we do know that angle V and angle S are corresponding angles. They are in the same spot. So if I could find angle S, I know angle V. Well, from triangle angle sum theorem, I know that the measure of angle S is 83, which is 180 minus 62. Here, I'll write that a different way. Minus 62 and minus 35. Excuse me, I'm having trouble writing for some reason. So if I know that angle S is 83, and it's the corresponding angle to angle V, then that means that the measure of angle V is also 83 degrees. Okay? Find X. So notice we're being told that these triangles are congruent. They're telling us which parts sort of match up with each. So I can see that angle M and angle C are going to match. So if I knew angle C, I could find out angle M. Well, I can find angle C because this is a triangle, and I know that triangle angle sum theorem, that the measure of angle C is going to be 180 minus 45 and minus the 90 that is being used, so it's equal to 45. Well, if angle C is 45, then M, which is being represented by 3x, is also 45. So 3x is 45, so x is 15. If we were asked to find t in this picture, I can see that 2t is representing LK and 4 is representing AB, and those are corresponding parts. So 2t must equal 4, so t equals 2. Okay. Are the following triangles congruent? Justify your answer. So in order for them to be congruent, we need all of their corresponding parts to be congruent to each other. So if I took triangle ABC, I'm wondering if it is congruent too, and now I have to fill in the order that these would need to be congruent. Well, I can see that angle B has 2 angle marks, and so does angle D. So angle D must be in the same spot as angle B. Angle A and angle E each have 1 angle mark, so angle A and E must match each other. And the only angle left in each of them is what we would call angle C. So this would be the way that they would match up if they do, but now we need to check all of these side lengths. And actually the angle as well. Angle C over here actually is congruent to this angle over here because of vertical angles theorem. So now I just have to see about the sides. Well, side AB and side ED, I can see that they correspond and they are congruent, so that's good news. Side BC and CD, BC and CD, they're in the same locations. They are congruent to each other. And then finally, AC and CE, AC and CE are congruent to each other. So these have corresponding parts that are congruent, so they are congruent. Okay, I'm going to skip that one. Last, just a random sort of theorem, third angles theorem. I just want you to be careful when you use this because students are often having trouble with this. But if 2 angles of one triangle are congruent to 2 triangles of another, then their third angles are also congruent. Okay, the reason this works, if you can look down at this picture down here, look, if angle A and D were each 30 degrees, and if angle angle B was 50 degrees, then angle E would also be 50 degrees. So the way we would solve for the third angle in the triangle on the left is the same way we would solve for the third angle on the triangle on the right. We would do triangle angle sum theorem. 180 minus 30 minus 50 is 100. That would be the measure of angle C if I did my math on the left, but that's the same angle measure I would get as the measure of angle F. So that's just handy if you see that 2 angles in 2 different triangles are congruent. What I just want you to make sure is that you are comparing 2 different triangles to each other, and that's pretty important when you're doing